Good morning, afternoon, or evening, depending on where you are, what time you're watching. So day 13, second part of implicit derivatives, we'll be doing some more difficult problems within there. And we're going to do 3 different examples today. And then tomorrow will be the practice day. So today will probably be about that 30, 35-minute video again. And practice will be saved for tomorrow. And then that will be the end of the derivatives instruction part. I will have a hand-in to do at the end with everything that we've done in derivatives. And I will also have a summary day with all the equations and rules for derivatives that we went through in the days that, 13 or 14 days that we've been doing this 2-3 weeks. Okay, so the first thing I'm going to do then is I'm going to do a more complex example, get my timer on there. So let me get my marker out here. Let's start off with a complex example that uses the product rule within the solution. And then we're going to do one that has a product rule with a negative in front of it to show you to be careful with your negatives, and myself as well, so that we don't make sign errors and things like that. And then we'll do a slope type example with a circle and an ellipse type problem. Okay, so let's get the marker here. Let's do example 1. And this is going to be just one that has the product rule in it. Is needed. Okay, so let's say that we have 4x squared y squared plus 3 equals 6y minus 5x. And we're going to find the derivative. Okay, so we're going to do implicit differentiation, but we're going to need the product rule here. So we're going to have to do the product rule. The rest of these we can just singly use the power rule with. But the product rule is going to be in there. So if we go f, using the product rule, fg prime plus f prime g. If we do that one. Okay, so I'm just going to do the product rule underneath here. So if we say that f is equal to 4x squared, f prime is 8x. If we say g is y squared, okay, then g prime is 2y, y prime. Don't forget to add that y prime after. Do the derivative. Okay, and then we're going to now apply the product rule and then apply the derivatives to all of these. Okay, so some people will just do the product rule in their head and not write this out. They'll just write it out like I'm going to write it out here. They'll go, okay, f is 4x squared, and then they'll go, okay, then g prime is times 2y, y prime, plus they'll go f prime is 8x, and then they'll go g, which is y squared. There is your product rule, plus the derivative of 3, which is 0, equals the derivative of 6y. So that's 6. The derivative of y is 1, and then you have to multiply it by y prime. So 1 times y prime is y prime. So, but you still have the constant out there. And the derivative of negative 5x is negative 5. So then we have to do a little bit of simplification here, and we have a y prime, and we have to bring everything to the other side so that we can get the derivative here of this particular, we're going to have to move this over here and this y prime over here. So we're going to have to bring all the y primes to one side. So what we're going to do is let's simplify this to 8x squared y prime plus 8xy squared equals 6y prime minus 5. Okay, so we're going to move this out of here by subtracting it on both sides. And we're going to move this out of here over to here by subtracting it on both sides. Okay, so what do we get when we do that? Okay, so this stays 8x squared y prime minus 6y prime. That's a 0 there, equals, this is a 0, and then this comes up, you can put it first if you want, negative 8x y squared minus 5. Okay, now this is where you have to, well, how do I get the y prime? Well, we factor it out on the left side. So once there's an expression of y prime in both, so there's a common factor of y prime here. So we factor it out, and we get 8x squared y minus 6 in brackets. And then we just leave this, negative 8x y squared minus 5. And now we can just divide out what's in brackets on both sides. So divide it out there, gets rid of it. Divide it out here, we get negative 8x y squared minus 5 on top. And on the bottom, we have this expression, 8x squared y minus 6. And that's our answer for our derivative. Now, the one thing that people often get confused about is they'll have, because you can have the negatives on top or the bottom, you could have similar answers. Like if they had this, if you moved everything over to this side here and then moved the y prime over to this side, it would flip the positive and negatives. So this could be a positive on top. You could have had, if you multiplied everything by a negative 1 on top and got plus 8x y squared plus 5 on top, this, all the bottom would be the exact opposite. It'd be negative 8x squared y plus 6. So this would be the same answer as this. You're just changing the top and bottom signs. If you multiply the top by negative 1 and the bottom by negative 1, you're going to get the same answer. So when you're checking your answers, if you get this and the answer says this, you're not wrong. Okay, so keep that in mind when you're checking answers. So that's our first example of product rule inside a large equation that we have to take the derivative that has a bunch of y's and y squareds and things like that. Now, this one had a positive in front. In the second example, we're going to do a similar type equation, but we're going to take time and we're going to put a negative in front to show you that you have to be careful with negatives, and you have to include that negative in your product rule, or you have to put brackets out front of it and put that negative in there so that when you're multiplying it out, you don't change signs or something like that. So let's go ahead and I'll show you what I mean by doing another example of that. So let's do that on the next page. Let's do one. We're only going to do 3 basic examples today. They'll take us a little while. So let's do our second example on the next page. So in this example, we're going to have an equation with a negative sign around the product rule. Okay, so let's make one up here. I've got one here that's not too difficult. 9y, minus 8x is equal to, let's say, 4x cubed minus x squared, y squared. There we go. We've got that negative in there. Okay, so what we're going to do is we're going to do the product rule here. Now, there are a couple of ways you can do it. I'll show you the way I like to do it. You could, when you do the product rule, just use negative x squared as your f and y squared as your, but what I like to do is I like to just do the product rule of this and then leave that negative out front. So we know that we're going to have f equals x squared, so f prime equals 2x, and we know that g is y squared, which is g prime is then 2y y prime. Okay, so if we know that, we're going to apply the product rule in there using those type things. So let me show you how to do that. Okay, so let's do this one first. Derivative of that is 9 times 1 y prime. So 9 times 1 times y prime is 9y prime minus 8 for the derivative of that equals 12x squared. For the derivative of that, keep the negative out front, put the product rule in here. So now we're going to apply the product rule, which, if you remember, it's f prime g plus fg prime, if you like. Okay, so f prime, if we do that first, we've got 2x, and g is y squared, plus, now we do the second part of it, which is f g prime, so f in this case with x squared, times 2y y prime. Okay, so now when we're doing this, we've got 9y prime minus 8 equals 12x squared. Now we're going to remove the brackets now with the negatives. Minus 2xy squared. And then this has to go in here as well. So minus, and then we'll put the 2 up front. 2x squared y prime. And then we have an equation now where we're going to isolate the y primes to one side and the numbers to the other. So we see the y prime over here and a y prime over here. So let's add 8 to both sides and add 2x squared y prime to both sides. You don't have to write out what you're doing. I just do when I'm explaining it, so you know if you look back in notes. So here we've got 9y prime plus 2x squared y prime. Okay, and then we've got, get rid of that 8, equals 12x squared minus 2x y squared. This is gone now, but we have that 8 in there, plus 8. So now we have all the material with the all the equations with the y prime in them on the left and everything on the right. So now we factor out the y prime here. So this is 9 plus 2x squared y equaling all of this, 12x squared minus 2x y squared plus 8. And we just divide it out. Y prime is then going to be equal to 12x squared minus 2xy squared plus 8 over 9 plus 2x squared y. Okay, and again, remember, you might have opposite signs on the top and bottom, and you'd still have the same answer, depending on how it goes. So that's quite a large one there. And that's the one I wanted to make sure that if you've got a negative in front of something that's multiplied, you could do it with this is negative x squared and then not worry about the negative in there and then just do the product rule and crunch it out, and it would work out the same as this. Or you could just keep it in brackets, do the product rule, and then distribute the negative. So either or is fine. Okay, and that's our second example today. And I have one final example that I want to do with a circle or an ellipse, where you're finding the slope of a tangent line to that circle or ellipse. And tomorrow I'll give you the practice assignment. It's only 6 questions long, but as you can tell, we did 2 of these and it took us 15 minutes or so. So 6 of them, it's going to take you, 30, 40 minutes to do anyway, depending on your, math skills and how fast you are with math and things like that. So, but that's for tomorrow. So our last example, our most complex example, is going to be an example with finding slope. I'm going to do this on the next page, and I'm going to type it out as well. Final example for today with the implicit differentiation. Let's type this one in so that it's a little bit neater. So this is example 3. This is finding the equation of a tan line to a circle or a curve. In the example, in the practice example, I've got one circle. Remember that circles are like x squared plus y squared equaling something, and the x and y squareds have the same number. So it could be like 2x squared plus 2y squared equals a number, or x squared plus y squared. That's a circle. An ellipse is where the number in front of the x squared and the y squared are different. So an ellipse would be like 16x squared plus 45y squared equals a number. So they have different numbers. So an ellipse then flattens out. Instead of being, just think a circle is perfect, so it has the same x and y squareds around it, and an ellipse will flatten out. So one number, the x or y, will be bigger than the other. Not that you really need to know that, but just if you're doing the sketches to help you think about it. Okay, so let's do the example here, and enough of me yakking. So find the equation of the tangent line to the ellipse with, let's say, with negative slope. To the ellipse. I'm trying to model it like the ones I got in the example. Ellipse, where's my ellipse? There we are. 9x squared plus 4y squared equals 13. Okay, I got to get the squareds fixed up in there. Oh, not root, you dummy. Clicking all over the place. There we go. Where is it? There we go. When you get older like me, your eyes start going, can't see things. Okay, so there's our equation with negative slope at the point x equals 1. Sometimes they'll give you both coordinates, but that's what this negative slope thing comes into play. And I'll show you the example of that one. I'm doing it here when I'm doing the solution. Okay, period. I just got to check. I'm going to pause for a second, check my phone as it went off there a little while ago, and I'll be right back with you. Okay, nothing important. Okay, so the very first step 1, is to find out which point you're dealing with. Okay, it's x is a 1, and what's the y? So now, if we draw this out, okay, I'm going to use my marker here again. Okay, so we have an ellipse. Okay, and this ellipse, okay, so the x is longer than the y. I can't remember exactly what it looks like in terms of, you could use Desmos if you wanted to type this in and see what it actually looks like, or you could just sketch it. I'm not sure if it's wider this way or wider this way. Yeah, let's use Desmos and check it out. Well, let's do the solution first, and then I'll show you on Desmos. So let's say that I'm just going to guess it's like that. It's around the origin. So now it's saying x equal 1. So that means you're going to have x equal 1. So let's say that 1 is up here, 1x. So that your point can be there or it can be there. So you can have a negative, this is a negative slope. And this is a positive slope. So if you can see by the sketch that I have, even if I had it like with the narrower thing, it's still going to give you the same idea. So this is going to have a positive y, and this is going to have a negative y. So which one do we want? It says the equation of a tangent line with negative slope. So we want this one. So when we solve this, our value is going to be a positive y. So let's solve it. So step 1, find y. Okay, so let's plug in 1 for x. 9 times 1 squared plus 4y squared equals 13. Okay, this is 9 plus 4y squared equals 13. Subtract 9, 4y squared equals 4. Divide by 4 on both sides. Y squared equals 1. So root both sides. Y can equal the root plus or minus the root of 1. So y equals plus 1 or negative 1. So now which one do we pick? Since we want the negative slope, we pick the positive one because it says with negative slope. So then our point is 1, 1. There we go. So that's step 1. We find the correct point. So in any circle, you'll have a negative choice and a positive choice for slope. Sometimes I'll just give you the point and say at point 1, 1 rather than say x equal 1. Okay, so now the second step then, after you've done that, you've got to find the derivative of the equation because the derivative equals slope. So step 2 is to find your derivative. You've got the derivative here that we're going to calculate from 9x squared plus 4y squared equals 13. So let's whap our derivative in. So that's 18x plus 8y y prime equals 0. Okay, y prime is here, so let's move the negative 8, the 8x, subtract 18x on both sides. And then let's divide out 8y on both sides. Okay, and let's reduce. So our y prime is equal to negative 9x over y. 4y, pardon me, because we had to divide by 2 on both. Okay, so that's our slope. Now, in step 3, we'll find our slope by plugging in our point 1, 1. Calculate the slope. Okay, slope is derivative represents the slope, so this will be slope equals, if we plug in the number, negative 9 times 1 over 4 times 1 equals negative 9 over 4. That's our slope. So now we have our slope and we have our point, 1, 1, and our slopes. Now we use the line equation to calculate, completely calculate the step 4 is to find the tangent line. Okay, so now what are we going to do? We take that equation of a line, y minus y1 equals m times x minus x1. Okay, the line is 1, 1, and the slope is negative 9 over 4. Okay, so we go y minus 1 equals negative 9 over 4 times x minus 1. Okay, we have to multiply everything by 4 on both sides. So 4y minus 4 equals negative 9 times x minus 1. Why didn't I multiply by 4? Because this is one term. Okay, this is considered one variable like that. You could expand it out and then multiply by 4. That worked too. So if we do that, we end up getting 4y minus 4 equals negative 9x plus 9. Let's move everything to the left by adding 9x and subtracting 9. So adding 9x would give us 9x plus 4y, and subtracting 9 from both sides would give us negative 13 equals to 0. There's our tangent line. And you'll notice there's a little pattern there. At that particular point, it gives us a nice equation there. That represents the equation of the tangent line with the negative slope at point x equal 1. Okay, so we're sitting around about 26 minutes or so. I'm going to leave tomorrow as our work period for the 6 questions I'm going to give you. You could start it today if you want. It's up to you if you have extra time. But just review quickly here. A couple of things. Okay, so larger derivatives, if they have any multiplications of x's and y's together, especially if they have powers, you have to use the product rule within it. And then what you do is you take all the expressions with y prime to one side and all the expressions without y prime to the other side, and then you take the common factor of y prime out, and then you divide it, and you get a value for y prime or derivative. And you have to be careful with it. If it's in fraction form, signs on the top and bottom, these two equations are equivalent to each other. So when you're checking answer, be aware of that. Okay, and if you have a negative in front of where you're using the product rule, don't get messed up with that negative. Either put the expression in brackets and then distribute the negative later like I did here, or use negative x squared as your f prime, or your f, pardon me, and then use that as you do the derivative and just write it out. And then the last one, when you're doing slopes at circles or tangents or ellipses, especially that are around the origin, one part will be above and one part will be below the x-axis. So one will have a negative slope, one will have a positive slope. Pick the right one when you're solving for the point. Once you solve the point, take the derivative of the equation, the circle or the ellipse. That derivative with the point plugged into it will give you the slope, and then you use the slope equation for a line to find out what that tangent line is at that point 1, 1. Okay, now just for interest's sake, let's plug this in to Desmos and see what it looks like. So I'll slide this over. Just for interest's sake, we got a few minutes here. If you want to check things in calculus, Desmos is great. Okay, let's bring over and let's get Desmos up here. Model your equation that we did here. Oops, I just want the graphing calculator. Let's hit that here. Okay, so get in here. We know that our equation that I had, if we look at it, was for our ellipse was 9x squared plus 4y squared square, not that thing. There we go. Equals 13. Okay, so I was wrong. It's actually thicker on the y squared part, but it'll still be there. Okay, and then if I put the line that we got for our answer, which if we look at our answer, what was it here? 9x plus 4y, you can plug that in. 9x plus 4y minus 13 equals 0. There we have our tangent with a negative slope, and this should be 1, 1. So we consider ourselves, okay, we got her. So you can use Desmos to check what it should look like if you don't want to do the sketch. There's our ellipse. There's our point of tangency at 1, 1. Everything looks good. Okay, so that let's close this down here. Okay, so that is where I'll leave you today. We're about at the 30-minute mark, so that's good enough. And I will bring up, tomorrow you'll be working on the practice assignment that looks like this. And there's just 6 of them there that you can do. And that's for tomorrow. And then we'll get into the review, and then we'll do the hand-in, and that'll be it for the derivative unit. See you tomorrow.